Hey there, welcome back to Coding at Home with the Code Hub. Hey there, I'm Matt with the Code Hub. Welcome back. We're on day 3 of, or day 4, I know what day it is, of coding with the Sonic Workshop Playground. We're just back from a pretty intense week with all the WWDC playgrounds. And of course, they were our inspiration for starting this new Sonic Workshop series, where it dives into a lot of the concepts and code that we're playing around with in our Sonic Workshop. We've been introduced to closures, which are kind of an advanced concept, and I'm going to show you sort of some further reading that you could do if you're really interested in it and you get really excited about this kind of thing. And then we're going to, of course, dive back into the code and start writing some of our own functions, and we'll start to use some closures of our own, and there'll be some new wrinkles thrown in here. So let's jump over to the iPad and we'll figure it out. So here we go. All right, so over to the iPad. What I'm going to show you first is actually the additional resources. So if you're approaching this material and you're like, oh man, I love closures, I want to learn more about it, I want to learn more and advance my programming knowledge, that's great. We can go and take a look at the books application. Now we use the books application to dig through Everyone Can Code puzzles a few weeks ago. And we learned all about Swift, and we learned a lot of the language fundamentals about functions and types and conditionals, loads of stuff. The next step in your programming journey, which would mean moving off of the iPad, if you want to build things like iOS apps for the phone, for the iPad, for the Apple TV or the watch, would be moving up to Xcode and a Mac. So if you are ready to make that step and you have that gear at home, you can download this book for free as well. It's called App Development with Swift. The Xcode 10 version is the most up-to-date version. If you tap on that, I just downloaded it from the bookstore. You can see here I'm already ready for closures because I'm super excited about it. I'm in the lesson 5.1, which is all about closures. And it explains how they work. It explains how they look and how they can look different in different scenarios, because there are lots of different ways you can write closures. Sometimes you can be very explicit about the parameters that a closure takes or what it returns. And then other times there's some sort of, they call it syntactic sugar, which is just an easier way to write the closure or the particular language feature where you don't need all the extra baggage. Now, the problem I have sometimes with syntactic sugar is that maybe it's not as clear, especially to beginners. So this chapter here, this lesson 5.1, gives you some great advice on how you want to write closures, especially when you're starting. But it also lets you identify closures that other people have written. So it's sort of a great guide. This whole book, if we look at the table of contents, so that's working with the web, that's unit 5. It starts out very, very gently, like we did with Everyone Can Code puzzles. It'll go through things like a bunch of Swift features here, operators, control, flow, constants, variables, and data types. All that stuff should sound familiar from Everyone Can Code puzzles. So that's a great starter. It starts to get a little more difficult when we get into the Xcode chapter, building, running, and debugging an app. This is more dealing with actual app development features. So it's the controls that you can add to the screen. So the controls like image views or buttons or sliders. And we've seen some examples of that in our Lights Camera Code playgrounds and now our Sonic Workshop playgrounds. But these are the built-in controls that you see in apps that you use every single day. So buttons and things like that. So it talks about documentation, where to find answers to questions you might have that aren't in this book. And for each unit, you wind up building a little project. In this one, there's a guided project called Light. Now, if you're following this along, obviously you're watching this on YouTube. Our Code Hub channel has a YouTube video that talks about getting started with Xcode. So if you go off to our channel, we're going to get a little bit of a weird feeling here for a second. So we're going to do the code hub /live will bring you to our channel. We'll probably see ourselves presenting here, which will be a bit strange. But we can see we have a series of different playlists. If you do want to start your app development with Swift journey, I have started an app development with Swift playlist where right now the only video in there is getting started with Xcode. It's a good 40-minute session where you learn your way around the interface and you start up a little sample app. It's not a very exciting sample app, but it's a starter. So that's your next step. So if this stuff is getting you really excited about programming, that's where we would go next. And I hope to produce some more videos on that topic in the near future. So that's where we're going in the future when you guys become full-on professional app developers. But for now, let's go back to our Sonic workshop and let's add some more crystals and gems to our scene. So I'm going to open up Swift Playgrounds. All right, so yesterday we were off on reusing functions. We had this, so we're in the crystals shared code file, and we filled out this function that was already defined for us. And the interesting thing that we might not have seen before was this arrow here, this ASCII art arrow with a dash and then a greater than symbol, followed by the type of object that we return. So in this case, we return a graphic. You can see I create a graphic here. This is my initializer. I set it up a little bit. I set an on-touch handler, so this code will be run when we touch the graphic. And then I use this return keyword to return my graphic back to the calling site. So if I go back to main, and I can see where I use this, I called create crystal twice, and it gave me two different graphics. That's another interesting thing to note, because it's not giving me the same graphic. It's actually going and creating a new one every time I call this function. So that was reusing functions. So that was something that had already been written for us a little bit. Now what we're going to do today, if we go to the Your Own Functions page, is we're going to write our own function. So it talks here about, okay, so we know about writing functions in a shared file. They're accessible to all the playground pages now. In fact, all of our code from the other day is still here in our Crystals Swift file. So now what we're going to do is we're going to create a new function in this Crystals file that we'll be able to call. So let's go on to the next page. We'll swipe over. So we have to write a new function definition. Now, the easiest way is to just kind of look what we've done up here and copy that. And if we tap on function definition, it'll tell us that function definition basically describes what a function does, what it expects to receive. Those are the parameters that we've been talking about. And then what it gives back to the caller when we're done. So we're going to write a new one. And in the body of our function, we're going to create a graphic, then we're going to return it we created. So it's a bit like this one here. Now, we can't call it the same thing because Swift will start to get confused. If someone calls create crystal and ours is named the same thing and it has the same parameters and the same return type, that means it has the same function definition or the same signature. And Swift is going to say, well, I can't decide which one I would send, which one I would run if you called create crystal. So we have to name it something different. And in programming, not just Swift, but in programming in general, it's very important that we pick good names for our functions. So we need to think a little bit about what it is we're going to do. So far we can see that we're going to create a graphic and return it. Okay, that's not super helpful. Maybe we'd call it create graphic. Maybe. I'd like to be a little more specific, but for now, that's all we know that we're going to do in this function. So let's call it create graphic. So we're going to make it public so anybody can call it. We're going to use our func keyword, and we're going to use the autocomplete here because then it helps us out by adding the name and then a placeholder for the body. So we'll call it create graphic to start. And I'm going to spell graphic right instead of graphic. Okay, let's see. So we're going to have this function. It's called create graphic. We're going to create it and then we're going to return it. All right. Well, we can kind of do what we did up here. We can say let graphic equal, and then we'll create a new graphic. So we'll use the graphic initializer by tapping on the type. And then we'll use the parentheses. Now we can pass in an image or a shape with a certain color. Well, we haven't been given a real spec for it yet, so let's start out with just a shape and a color. So a shape, I think there are some built-in ones, so we'll use the dot to see if there's some built-in ones. Yep, cool, we've got circle, rectangle. Let's use a circle with a radius of, say, 20. And then for a color, we have the same thing. There's some built-in colors, so I can say, actually, let's use the color picker. And let's always make it that color. Maybe not blue, because then it'll clash with our underground thing here. So let's pick a different color. And now we need to return this graphic. So you saw we did that up above by typing return graphic. So we'll do that. Return graphic. Okay. Now we have an error here. Let's check out let's see what's wrong. So it says unexpected non-void return value in void function. All right, that might be a little bit mysterious, but what's the one thing we're missing here? So when we talked about the function definition, we talked about the parameters that it accepts, and then we talked about the return, the item that it returned, the type of item that it would return. We actually need to put in this little arrow, because right now this function says I'm not supposed to return anything. So if somebody calls create graphic, I'm just going to create it, do whatever I want to it inside the body of my function, and then that's it. I won't give it back to whoever called me. So now we have to add a return type. And luckily, if we tap on this function definition, we can just say, all right, cool, add return type. And it'll give us some helpful options here. We're going to return a graphic. Now, if we just wait a second, we'll let it build, and then we should be good to go. There's no red dots. So we return the graphic with a keyword. Now we're going to call our function in the main file. So we're going to store that graphic in a new variable and then place it in the scene. So let's tap on the main file. And we'll go back to the crystals file in a second because we're not done yet. We're still working on it. We've just created this function. There's a lot of setup work to think about here and to understand how we're going to use this. So let's call it. Let's create a variable to store our graphic in. So I'll actually just call this graphic. I could call it anything. I could call it gem. I could call it circle. We're going to call our function by saying create. And there's our create graphic option. You can see there are no parameters. It might be nice to have some parameters so we can change this radius of the circle to make it bigger or smaller and maybe add some sounds. But we'll look at that in a second. Now that we've created the graphic, let's place it on the scene so that we can see what we've created. And we'll place it smack dab in the middle. So scene dot place. And since we have a graphic, we can place that graphic. And the point we're going to place it at is going to be right in the middle. So use a point initializer. And you notice that I often tap on the double one. Sometimes I'll tap on the int one. It doesn't matter because when we type in the numbers here, Swift will actually figure out whether we need the double or the type or the int initializer. So let's hit run my code. So now we've got all of our pieces in place. We've called our new function, create graphic. So if we tap on crystals, it comes in here. It creates a graphic of a certain shape with a certain color. It returns it. So we jump back out to main. We store it in that variable, and then we place that the contents of that variable onto our scene at 0, 0. So let's run it and see what we have. Okay, there we go. It's a bit small. Maybe we want to make that a bit bigger. We can't tap on it to get sounds or anything yet. It's not super exciting. We're playing our underwater music on the scene. So let's stop that. Now let's have a quick look at the help here. Because while this is fine, I feel like we've taken a step backwards. Because now it's not interactive. We can't change the size of the graphic or anything. Let's go take a look at our first need help under the function definition. Okay, so what they intend for us to be able to do is have someone pass in an image and a sound, a lot like this create crystal function, and return a graphic. So let's add some parameters to our function to make it a bit more interesting. So if I go over here and I tap on my parentheses at the end of create graphic on my function, I get this blue dots and then these 2 dots here. I can actually drag out to add parameters. So let's add an image image, and it's going to take a type of image. So we'll tap on the image type. Now the next thing we need to do is we need to take a sound as well, because this is Sonic Workshop after all. So I'll have a sound parameter. We use a sound, and then we want to take a type of sound. So let's go have a look. We have Sonic Music and Sonic Sound. Let's pick Sonic Sound as the type of sound parameter that we're going to get. Okay, so now our function signature matches this one. You'll note that if we followed these instructions to the T, we would have had a compiler error. And in fact, we have a red dot now, so let's see. It says, oops, we have an error. Let's go check it out. It's in main. And it says, we're missing an argument for parameter image in this call. Well, let's fix it. Let's hit the fix button. All right, so now we can add an image. We're going to use our image literal style. So let's go grab an image literal here. And let's see, we'll add this image there as our graphic. And I have another red dot. So let's tap on the red dot again. Ah, it's telling me I'm missing another argument for the parameter sound in the call. So let's go tap on fix. We're going to tap on this Sonic Sound placeholder, because if we tried to run it now, we'd get an error saying, oops, we need to fill in this placeholder. So now that it's highlighted in blue, I'll just go down here and say dot, and it'll give me a list of all the sounds that I have access to. Let's do the can you hear me? All right, let's run our code. All right, well, we don't have, this image is just kind of thrown away now, and we're not doing anything with this sound. Maybe we want to update the body of our create graphic function. So we'll hit stop. We'll go back to the crystals file. And let's see what else they have here. So in need help, we need to return the graphic we created. So let's tap on this to see what it looks like. Okay, so they're creating a graphic with an image rather than a shape. So let's change it. Let's change ours. I'm going to tap on the, missed. I'm going to tap on this closing parentheses here. So now I can just delete that whole section because we'll initialize a new graphic. So I'm going to start typing in graphic with a capital G. There we go. I'll use this open parentheses, and we'll use the image initializer rather than the shape one. Now the image that we can use to create this graphic is the image that's passed in, so we can refer to that with this lowercase image reference, so we'll tap on that. So now let's try running it and see if that's fixed our issue. Okay, cool. So our red dot's gone away. Now we have a giant gem in the middle of our scene. It still doesn't play music, but that's okay. We haven't written the code for that just yet. So we'll stop that. Now let's see, what other help did we have here? So we needed to create a new, it gives us some help for creating a variable. Well, in this case, they have a mushroom variable, and they initialize it with whatever the function name is we named it. So create graphic, an image that we pick, and a sound that we pick, and then they place it at -40 and -200. Well, I'm kind of happy with where we put ours. We don't need to do mushrooms here, so we'll leave that as it is. This is what ours looks like. Now let's hit continue to go to the next section. Okay, so now we add a new wrinkle to our closure syntax. So now we want to trigger our graphic to do something when we touch and drag across it. So we're going to write our code above the return statement in our function in the crystals file. And it's going to look like this. Graphic.setOnTouchMoved handler. And then we start the curly braces. And then just after the curly braces, we have this touch keyword. And then it says in. That's definitely a keyword. And then there's a sort of space. And then there's the closing curly brace. Let's find out what this touch in means. And while we're looking at that, I'm going to tap on the crystals file. So we're back there and ready to mess around in our new function. So this touch moved handler takes the location of our touch as an argument. So because a closure is just a function without a name, they can still take parameters so that you can make your function and the way it behaves a little more dynamic and a little more useful if we could pass information into it. So the way you write that is by using this in keyword. So we name our parameter, and then we use the in keyword to say, hey, the next stuff following this in keyword, that's going to be the code that I need you to run. So let's do this. Let's try this experiment here. So inside of our handler, we're going to write our handler in here. Going to hit return. Our onTouchMoved handler is on our graphic. So we'll say graphic dot. We'll scroll way over. And you can see we have our old handler, right, that we used up here, setOnTouchHandler. Then we have this setOnTouchMoved handler as well. So now we can give it a handler with, and this funky looking syntax here is this is the name of the parameter, handler, inside this function. And then this syntax here where we have the open parentheses, and then we have another one, and touch inside the first set of parentheses. We have an arrow returning void, which means returning nothing, and then a closing parenthesis. So everything inside these parentheses here, that's our function definition. So that's how we know that there's going to be a parameter. So let's follow their example over here. We're going to do touch in. All right, so let's start typing touch in. Touch space in. We'll hit return. Now we're going to have some issues with this. Because can you see the difference between what I've started typing and what's over here? So the way the closure is called in this case is we set the onTouchMoved handler. Right now I have parentheses around my touch in, and they've got curly braces. So we want to make sure that we change that. We don't want to change touch. So I'm going to hit the space bar and hold it down until it goes to the front of the word. I'll add a little space and I'll drag down over the F key. And in demonstrating, I added an F. So let's drag down over the F, down to the right. Oops. And so there's our touch in. Now we've got all sorts of red here because we've got a parentheses closing where we should have a brace. So we'll tap on that and change it. So I'll go drag down to the left now over my F to get a closing brace. Okay, cool. So now I've got my touch in. And if we look down here in the code example they have, they do some sort of magic here. So what they do is they take, the touch has a property called position, which is very like the point that we've been creating, right? Where it has an X and a Y coordinate. So the touch will tell us where on the image we're actually touching X from an X and Y coordinate standpoint. And what we do here is we take the absolute value of that. So if it's a negative number, we'll turn it positive. If it's a positive number, we'll leave it alone. We divide the touch position by the graphic width. There's a size property on our graphic. And then on the size property, there's a height and width property that we can access. And that's just a number. So we'll divide our X position by the width of our graphic. We'll set the saturation of our color to 1/2, the brightness to 1.0, and alpha to 0.6. Okay, all right. And then we set the tint color of our graphic to that color that we just created based on the touch. And then we blend it 1.0. Some of this seems a little bit like magic. Let's try it and see what it results in. So after the in, we hit return. And you can see Swift Playground's indents for us a little bit, so we can kind of see visually that, okay, this code belongs inside this function because it's indented a little bit. So we'll do the same thing. We'll do let color equal. Okay, and then we have to create a color. So we're gonna do this. We're gonna start typing color with a capital C because that's the type. I'm gonna tap on autocomplete. I'm going to tap on the parentheses. And this is our initializer for our color. With our hue, our saturation, brightness, and alpha. So we'll tap on that. Now hue is the one where we did that kind of funky math. And we used fabs. So let's set the hue to fabs. We'll just start typing fabs. This is a function. So to call the function, we need to use our parentheses. We're going to call our touch parameter. We'll get our position from that. And if we hit dot, we'll see that we have the choice of picking the X or the Y coordinate. We'll pick the X coordinate. Now that we have that number, we're going to divide it by the graphic's width. So I'll go outside my parentheses. I'm going to grab this symbol here over the B for divide. And now I'm going to type in graphic. We'll autocomplete. And we're going to use dot notation to access first the size and then the width of that size. So let's go find size. Wait at the end, so we'll hit size. We'll do dot width. Saturation is 0.5. Brightness is going to be 1.0. And the very cool thing about this is once we have these numbers in, we'll be able to play around with them and see actually what it's doing. All right, so that's our color, but now we need to set that as a tint color for our graphic. So we'll hit return. And we're just gonna, it's a function we can call on graphic. So we'll do graphic dot. We'll scroll over and find set tint color. There are two completion handler ones. So let's set tint color. Our color will be, of course, this one that we just created. So we'll do color. And the blend will be, what was it? 1.0. All right, let's try running this and see what happens. Okay, so there's our graphic. There's our music. I'm going to go over here and tap. If I tap on the screen anywhere, nothing's happening. If I tap on my graphic, we can see my gem changes color a bit. So if I go down near the bottom, I get one color. It should stay the same if I drag straight up and down because this X position isn't changing at all. And it should only change when I drag across the image like this. Now if we change this touch position to Y, here it is in our autocomplete. We're going to run it again, and you'll see that now the color is going to change when I drag my finger up and down. So first I'll start out by dragging across like this. Okay, so it's staying roughly the same. I think I'm moving my finger a little bit up and down. But now I'm going to drag my finger down and up. So that's kind of an interesting use of my touch position to determine what color I'm going to show. That's kind of a cool way to generate dynamic-ish looking colors. Now, I highly recommend playing around with all these values: saturation, brightness, alpha. The alpha just means how transparent or opaque a certain color is going to be. And things like this fabs is something that you can go look up yourself. It's you can just search for Swift fabs function, and it'll tell you all about some of the interesting math functions that are available to you in Swift. Maybe we can play around with that at a future date. But this is a pretty good start. This is kind of cool. This is something new that we've got. Now, an interesting note here. So this in keyword we have to use as is. We need to always have in. I could have named this anything. Now, we called it touch because that's what it represents, is a touch type. So it makes sense to call it touch. We could have called this anything. We could have actually said, there's no rename functionality here, but we could have said, this would be an example of terrible programming, but if we called it gerbil, we could rename, we just have to rename all of our uses of it down here, but we could have called it gerbil. It's just like any other variable that you create. So if I run my code now, I'm using the Y position from our gerbil. So when I drag up and down, the color on my gem changes. Now, of course, gerbil, like I said, is a terrible name for my parameter name. So I'm going to name it back to touch. And this is a huge amount of code already. Now it's been about half an hour of us working away at this thing. This is pretty impressive. It's nice that they wrote a bit of code for us to figure out how to get a changeable color based on those touches. Now, from looking at this, you have to guess that as my finger moves up and down, this onTouchMoved handler is getting called a lot. So all this code is getting run hundreds of times a second as I'm dragging my finger up and down. Because it's sending all these touch events in here, it's calculating the new color hue, and then it's setting the tint color of the graphic. So there's actually a lot of stuff going on under the hood. It doesn't look like it, because we've just hit run our code. So you might think that, oh, actually this just gets called once and then we're done. This actually gets called a ton. And it's more even than this. The on touch handler, this one just gets called when we tap on the graphic the first time. This one gets called every time we move our finger after we've touched down. All right, and we wrote all of that code. So after we placed our graphic, the only thing we really had to go change here, and the last thing we had to change was the signature that we were using to call this function. So our create graphic function, instead of just calling it with no parameters, we added an image and a sound parameter. And that's the last thing we did. So all of our code happened in this crystals file. So now if we move on to the next page, we'll be able to use this create graphic file just as easily from there. In fact, I might rename it, because now that we've sort of figured out what we're going to do with the graphics that we create in here, I might rename this function. So let's tap on create graphic. The whole point of creating this graphic is to be able to add this set on touch moved handler. So maybe we should say create touchable graphic or something like that to let people know that, hey, you're going to be able to do stuff to this if you tap on it. So maybe let's call it create color changing graphic. And if you're following along at home and you do name yours create color changing graphic, I recommend naming it in the American style color, just so you have less letters to type. But you can call it whatever you like. If you're typing this in England or Ireland and you're native of either of those countries, you could call it create color changing graphic, so long as that's how you call it in the other file. I'm going to call mine create color changing graphic. I'm going to tap on my main file. I have an error here. And it's going to say use of unresolved identifier create graphic, because I changed the name of this function. So we're actually going to type in create color changing. And you can see I have my autocomplete here that I'm not going to use because I already have my image and sound defined there. Graphic. And then, I actually lost it, so just kidding. I'm going to use this one again. We'll pick an image again. Let's see, we'll use maybe mushrooms because I know they referred to mushrooms in the earlier instructions. We'll use a sound, so dot creepy 2. Now we're not doing anything with that sound just yet. But now if we run our code, I have my mushroom. When I move my finger up and down, it gets all sorts of crazy colors. All right, not bad for a day's work. So I recommend playing around with those variables. Try playing with, if we go back here, playing with the brightness, alpha, saturation, change the touch position around. Maybe try to get the graphic to do something else. Maybe you have it change its position based on the touches it receives. Play around with it. We'll be back again tomorrow. We'll be working through this page. This your own functions page is huge. There's a lot in here. So we're going to add a sound now. So we are going to use that sound that's passed in. And yeah, we'll see you tomorrow for some more work in the Sonic Workshop. All right, see ya.